All right, so in this lesson, we're going to talk about the complex number system and solving quadratics by the square root method. So up until this point, you have been working in the real number system. There is another number system called the complex number system. So what it works with is what is called the imaginary unit. And the imaginary unit is denoted by I, and it's the number whose square is -1. So up until this point, we know that a negative times a negative gets me a positive. But if I bring in now this imaginary unit in the complex number system, I am able to square a value and get a negative number. So the definition of these is that I get I squared is -1, I is the square root of -1. So I to the first is I squared is -1. And then we get two more values that are going to be really helpful, I cubed and I to the fourth. So I cubed, I can rewrite this to see how this works. I get I squared times I. And I squared is -1 by definition. I to the first is I. -1 times I would get me a value of -I. And then I to the fourth, I can rewrite as I squared times I squared, which would be -1 times -1, which when I multiply those, I get a value of +1. So these four values are going to allow us to evaluate any values of I. I could have a power to the thousands, and I can still be able to find it very quickly. So how it works is when we evaluate these things, we're kind of going to be dividing by 4, and then I'm going to ask myself, which of these 4 powers is it equal to? So I'm going to start, I got I to the 7th. What I'm going to do is I'm going to divide my exponent by 4. So 7 divided by 4 is 1.75. And to see which power of I out of these 4 that it's equal to, I'm going to look at my decimal point. So I have 0.75, and I want us to think like we have quarters. So 1 quarter is 25 cents, 2 quarters is 50 cents, 3 is 75 cents, 4 is $1. So I have 1 and some change of 75. That decimal tells me that this is equivalent to I to the third because I have that decimal of 0.75. And I to the third is -I. So that means I to the 7th is also -I. If I want to go to the 26, I'm going to do the same thing. Take that 26 and divide it by 4. When I do that, I get 6.5. So same thing, I'm going to go ahead and look at that decimal. So I have 0.5, it's like 50 cents, I have 2 quarters. So I to the 26 is the same value as I squared, and we, by definition, know I squared is -1. So I to the 26 is also -1. We can also multiply, add these values together. So I to the 52 plus I to the 101, same thing, I'm going to take these exponents and divide. So I know 52 divided by 4 is 13, a whole number. 101 divided by 4 is 25.25. So I look at my decimals. My first one has no decimal. So this is equivalent to like having $1 whole because there's no decimal on that. So this is equivalent to I to the fourth. And then my second one has that decimal of 0.25. So this is equivalent to I to the first power because it's like having that 25 cents, 1 quarter. So we know I to the fourth is 1. I to the first is I. So 1 plus I. And we cannot combine these. And so that is my final solution, 1 plus I. And now last one. So I got 110, 32, and 57. So I'm going to start 110 divided by 4 gets me 27.5. 32 divided by 4 gets me 8. 57 divided by 4 gets me 14.25. So I'm now going to go ahead and look at my decimals. So my first one, I to the 1/10 is equivalent to I squared. So I got 2I squared plus then 3, this is equivalent to I to the 4th. And then I to the 57th is equivalent to I cubed. So minus 5. 57 divided by 4. Oops, sorry, that's going to be equivalent to I to the 1st. Okay. So now I'm going to go ahead and I'm going to evaluate these. So I got 2 times I squared, we know is -1. Plus 3 times I to the 4th is +1. Minus 5 times I to the 1st is just I. And now I can simplify these first two terms. So I get 2 to the -1st is -2, plus 3 times 1 is +3, minus 5i, and I'm going to go ahead and combine because I have two whole numbers, so my final solution is 1 minus 5i. Okay. So now getting into full definitions, complex numbers are of the form a plus bi, where a and b are both real numbers. A is considered the real part, the real number. B is the imaginary part of the number, and I is that imaginary unit. So when we add and subtract these, we add and subtract real from real and imaginary from imaginary. Okay. All right, so if I have these three complex numbers that are given to me, the first one I want to add z1 plus z2. So I have 3 plus 7i plus negative 5 plus 11i. All I'm going to do is, again, combine real with real and imaginary with imaginary. So I have 3 and negative 5, and then 7i plus 11i. So 3 minus 5 is negative 2. 7i plus 11i is plus 18i. And we just added those complex numbers. So again, it's not really any different from the addition that you've kind of seen before. Subtraction, so z2 minus z3, so I'm going to do negative 5 plus 11i minus then 9 minus 13i. Now the only thing with subtraction, just like when you subtracted polynomials, you do have to make sure that you distribute that negative to both terms. So I have negative 5 plus 11i minus 9 plus 13i. And I got, again, real with real, imaginary with imaginary. So that gets me negative 14 plus 24i. So now this says if I have another complex number z4 and it's equal to z3, I want to know what the value of a minus b is. So this is working with that first rule, equality. So two complex are going to be equal if and only if the real parts are equal and the imaginary parts are equal. So if z3 is equal to z4, we know z3 is 9 minus 13i. This has to be equal to a plus bi. So this is telling me that a has to be 9 and that b has to be negative 13 because, again, in order for those to be equal, those real parts and imaginary parts have to be the same. So now if I just go ahead and subtract a and b, I get 9 minus negative 13, which is 9 plus 13, which is 22. All right, so now getting into multiplying. So you can just go ahead and it is distributing the two binomials, multiplying the binomials together. So to multiply, I'm going to go ahead, I'm going to do 5 times 2, 5 times 7i, 3i times 2, and then 3i times 7i. So 5 times 2 gets me 10. 5 times 7i is going to be plus 35i. 3i times 2 is going to be plus 6i. And then 3i times 7i is going to get me 21i squared. And just remember that I times I is that I squared. So now what I'm going to do is go ahead and combine, see what I can work with. So I have these two like terms in the middle. So I'm going to do 10 plus 41i plus then 21. We know that I squared is the same thing as negative 1. So I got really 21 times negative 1, which is really negative 21. And then now I have two more like terms, so I have two real parts. So my final solution is going to be negative 11 plus 41i. And then you will see always the real part written first and then the imaginary part. Now we can go ahead and do the other one. So I'm going to go ahead and distribute this all out. So 3 times 2 is 6. 3 times I is going to be plus 3i. Negative 4i times 2 is negative 8i. Negative 4i times I is minus 4i squared. I'm going to go ahead and combine those two imaginary parts. So I got 6 minus 5i minus 4 times I squared, which we said was negative 1. So I have 6 minus 5i plus that 4. And I can go ahead and now combine those two, which gets me 10 minus 5i. So that's how we multiply. Now getting into dividing. So every complex number has what is called a conjugate. A conjugate, it's denoted by z with that bar above it. And the only thing that is different is the sign between the real part and the imaginary part change. So an example would be if I give you the complex number of 2 plus 3i, the conjugate to that would be 2 minus 3i. Okay. Another example. So just look at that complex number z. This is the conjugate. If I gave you another number, complex number z of negative 4 minus 5i, its conjugate, again, the only thing that changes is the operation between the real part and the imaginary part. So its conjugate is negative 4 plus 5i. Okay. And then there is this property that is going to make dividing these a little bit easier. If you multiply a complex number by its conjugate, it will always be the real part squared plus the imaginary part squared. That's just a little fun thing. So when you go to divide, what I'm going to do, the first step is I'm going to multiply by the conjugate of the denominator. So we know the conjugate of 5 minus 12i is 5 plus 12i. So what I'm going to do is I'm going to multiply that to both my numerator and my denominator. So 5 plus 12i over 5 plus 12i. And now what I'm going to do is I'm going to multiply everything out. So just like we did before. So multiply. So I'm going to distribute. So starting with that numerator, 1 times 5 gets me 5. 1 times 12i is going to be plus 12i. 4i times 5 is going to be plus 20i. 4i times 12i is going to be plus 48i squared. And now I'm going to distribute out the denominator, but then we're going to see the property that I just talked about. So I get 5 times 5 is 25. 5 times 12i is plus 60i. Negative 12i times 5 is minus 60i. And then negative 12i times positive 12i is going to be negative 144i squared. And now what I'm going to do is I'm just going to simplify all of this out. So I can simplify my numerator. So I'm going to start, this gets me 5 plus 12i plus 20i is plus 32i. And then plus 48 times negative 1. And now if I see in my denominator, the 60i and negative 60i, those are going to cancel out. So that leaves me 25 minus 144 times negative 1. And so I can just go ahead and keep on going. So I have 48 times negative 1 and 144 times negative 1. We know is going to change the signs. So this gets me 5 plus 32i minus 48 over 25 plus 144. And then I have those last two like terms to combine in my numerator along with my denominator. So this gets me negative 43 plus 32i over 169. And then what I am going to do is I am going to split this into a real part and an imaginary part. So I'm just going to write this as negative 43 over 169 plus 32 over 169i. And that is what we get when we divide those complex numbers out. So it is just that one extra step of multiplying by the conjugate, but then the only difference is that now I'm multiplying twice, and then it takes a little bit more simplifying. And then also, again, that denominator we see multiplying by the conjugate does give me that a squared plus b squared. So 5 squared plus negative 12 squared got me that 169. All right, so next one, same thing. I'm going to multiply by the conjugate of the denominator. So I'm going to multiply by 4 plus 3i over 4 plus 3i. So now I'm going to go ahead and multiply. So starting with my numerator, this is going to be 8. 2 times 3i is 6i. Negative 3i times 4 is negative 12i. Negative 3i times 3i is going to be minus 9i squared. And that's all over. I am going to save time because we saw the multiplication part on this one. But if you would rather multiply it out and that's going to make it easier for you, then go ahead and do that. I just want to remember that a complex number times its conjugate is always a squared plus b squared. So I know that this is going to be 4 squared plus negative 3 squared. I can then now go ahead, simplify that numerator. So I got my two like terms to start, and I got I squared to evaluate. So I get 8 minus 6i minus 9 times negative 1 all over 16 plus 9. So this is 8 minus 6i plus 9 over 25. And then I got those two like terms to combine. So I have 17 minus 6i divided by 25. And then last thing I'm going to do is rewrite it as a real and a whole, or real and imaginary. So 17 over 25 minus 6 over 25i. Okay. All right, now getting into square roots and complex numbers. So up until this point, you were not able to take the square root of a negative number, but when you work in the complex number system, then you can take the square root of a negative number. And all that happens is you pull out an I. So how this works is if I start with the square root of negative 100, in our brains, we know that the square root of 100 is 10. But now the only thing that's different is I have this negative in front of it. So when you have a negative, you're going to pull out an I. So the square root of negative 100 is 10i. All right, next one, I got the square root of negative 32. So simplifying square roots as a reminder, we are looking for perfect square factors. So these are things like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, just to do the first 12. So I'm asking myself, which of these are factors of 32? So 32 is 16 times 2. So what I can do is I can rewrite this as the square root of negative 16 times 2. And what I can do is I can now split kind of this up. So I know the square root of negative 16 is going to be 4i. And then the square root of 2 is going to stay because I can't simplify that. So I get 4 times the square root of 2i. And you can go ahead and combine those real parts together as long as that imaginary is tacked onto it. All right, so now I got the square root of negative 108. So I know that 108 is 36 times 3. So I have negative 36 times 3. I know the square root of 36 is 6, and since it's negative, I am going to pull that I out. So I have 6 times the square root of 3i. And the last one I got is negative 180. So I know that 180 is 36 times 5. So I have negative 36 times 5. And same thing, the square root of negative 36 is 6i, and then I still have the radical 5. So I have 6 radical 5i. So that is how we can now take square roots of negative numbers. All right, now solving by the square root method. So what we do when we solve by the square root method is we look at our quadratic and we see, is there no x term? So you use this when your b value, so if I think standard form, that we worked with when factoring is ax squared plus bx plus c. We use this method when your b is 0, so when there is no middle term. We also solve by the square root method when we have what is called vertex form. So this would be like a times x minus h squared plus k is some number. This is, when you see an equation like this is the method that we would use. It's called solving by square roots. So to solve by square roots, what you first need to do, step 1, is isolate the squared term. Okay. All right, once the squared term is isolated, step 2 is that you are going to square root both sides. And then step 3 is that you are going to then solve from there. So with my first one, I got 2 times the square root of, or 2 times x plus 1 squared is equal to 18. So the first thing I need to do is divide by 2 to get that squared term alone. Because again, what I am trying to do is I'm trying to get this term alone. So when I start, I divide by 2. This gets me then x plus 1 squared is equal to 9. Now, since my squared term is alone, I am going to square root both sides. So remember, square root and squaring cancel out. So that's gone, that's gone. This leaves me x plus 1 on my left side is now equal to, we always need to put plus or minus when we solve by the square root method. So the square root of 9 I know is 3. So x plus 1 is going to be plus or minus 3. And now I just need to solve for x. So I need to subtract 1 from both sides. So I get x is equal to -1 plus or minus 3. Now when you get the solution in this kind of form, what you need to do is see, can it easily simplify? So this one can. I get x is -1 plus 3, or x is -1 minus 3. And when I do that quick math, I get my 2 solutions of x is 2 or x is -4. And those would both be solutions to this equation. All right, so next one. So I got 7 times x minus 2 squared plus 8 is equal to 281. So I'm going to start, again, I'm getting this squared term alone. So the first thing I need to do is subtract 8 from both sides. So I subtract 8, this gets me 7 times x minus 2 squared is equal to 273. The next thing I need to do is divide by 7. So those 7s are going to cancel out. So I get x minus 2 squared is equal to 273 divided by 7, which is 39. And now what I'm going to do, since my squared term is alone, is I'm going to square root both sides. And we got to make sure we don't forget the plus or minus. So square root and square cancel, leaving me x minus 2 is equal to plus or minus the square root of 39. And then last thing to do to get x alone is add 2 to both sides. So I get x equals 2 plus or minus the square root of 39. Now I just need to see, can I simplify the square root of 39? There are no perfect square factors of 39. So this is my final solution, is 2 plus or minus the square root of 39. Next one. So I got 2x squared minus 5 equals -35. So again, step 1, get this x squared alone. So I'm going to add 5 to both sides. So that gets me 2x squared is equal to -30. Then I need to divide both sides by 2. So I get x squared is equal to -15. Square term is alone, so I need to square root both sides. Don't forget that plus minus. So I get x is equal to plus or minus the square root of -15. X is alone. Now I just need to see, how does this simplify? When I take the square root of a negative number, like we just did at the top of the page, I know that I have an I. So x is equal to plus or minus the square root of 15, I. And the square root of 15 can't be simplified any further. So that is my final answer. Final 2 answers. All right, and my last one. 9 times the square root, or 9 times x plus 3 squared minus 5 equals -99. So again, got to start by getting this x plus 3 squared alone. So I'm going to add 5. So I add 5. This gets me 9 times x plus 3 squared is equal to -94. I then got to divide both sides by 9. So I have x plus 3 squared is equal to 94 over 9. Square term is alone, so we're going to square root both sides. And we know by this point, plus minus. So on the left side, that leaves me x plus 3 is equal to plus or minus time of the square root of 94 over 9. And then I'm going to go ahead and subtract 3. So I get x equals negative 3 plus or minus the square root of 94 over 9. Now a little side note here. Oh, and sorry, these should be negative 94s. Forgot to carry that negative down. So a little reminder on radicals. So you can split a radical up. So I can rewrite this whole term as the square root of negative 94 over the square root of 9. And we know that the square root of 9 is 3. So I am going to rewrite this as the square root of negative 94 over 3. So I have negative 3 plus or minus the square root of negative 94 over 3. And then, since I'm taking the square root of a negative, we know we're going to pull that I out. So my final two answers are negative 3 plus or minus the square root of 94 over 3